Hey, talking about math industry, and we are going to take a look at the kinematic equations. So, in the last video, we were talking a lot about acceleration, speed, velocity, scalar, vector quantities, but here, in this video, it's going to be a little bit different. Try solving this math problem using one of the formulas that we actually have learned. So here is the problem. How far can a brick starting at rest fall freely in 3 seconds? So we're trying to find the distance a brick can fall when it has went from rest all the way to 3 seconds of falling. How far did it fall? If you're wondering how we can solve this problem out, it's going to be hard if you try just using acceleration only or speed only. And if you try and do that, not all the variables and the stuff is going to be there for it to help you. That means some of the variables there are not going to be there to help you anyway. But what if I told you that there are 3 new formulas that could help us fill in the missing information? So there are 3 formulas. The first one is going to be right over here, and it is V equals VO plus AT. So that's velocity equals initial velocity plus acceleration multiplied by time. So this is called the final velocity. And the strange thing is that this formula cannot really be alone because this is not really the actual formula to solve actual velocity. This formula is actually supposed to help us understand how to solve this problem too. Because if you try and map out all of the information, you're going to be missing some things. So that's why this formula is modified just for this special occasion. The next formula is going to be a little bit different. So this one's called the displacement formula, but not actually calculating actual displacement because it's supposed to be just for these kind of problems that don't have the same information. So your displacement is going to be your initial velocity plus n times, your initial velocity times the time 1/2 of the acceleration multiplied by time squared. Yeah, so this one is a very complicated one because you literally have to say times time and blah blah blah. Oh yeah, and this also is a modified formula that is special for these kind of problems. Oh, and the last one, velocity squared. So your velocity squared is going to equal your initial velocity squared plus 2 times the acceleration multiplied by your displacement. So those are the 3 formulas that we're going to help solve this problem. So yeah, let's solve it out. So remember in the first part of the video how we said that there's missing information? Well, here's what happens. So here are the different boxes that we're going to use. Because the strategy that we're going to use is called speed dating. So speed dating happens when we try to pull out information that we have in a problem, put them in boxes, and try to find out what one of these formulas we will need to solve that missing information. So for example, how far can a brick starting at rest fall freely in 3 seconds? So we're trying to understand how far the brick falls in the 3 seconds. So we know that our time is going to represent 3 seconds. But what if I told you when you say a brick starting at rest means that you're basically holding the object in the air and you let go of it and let gravity do the rest of the physics. Basically, you see this marker right here that I'm writing with it, but this is what happens, right? Yes, it's at rest. And there it goes. So what happens is our initial velocity is going to be 0 meters per second. But we have no idea what our final velocity is because we have no information of that. And plus, we're not really trying to find the final velocity. So instead, we are going to say not applicable because we're going to use the exclamation mark and the question mark for something else. We already understand that our letter A represents the acceleration. And we're also going to say that it's 9.8 meters per second. Because that is the gravitational pull and the gravitational constant of Earth. Anything that falls will fall at this speed. If I throw a feather and a baseball down, the feather will get to the ground the feather will get to the ground after the baseball because of air resistance. But if there was no air resistance, then both will fall to the ground equally. The problem is we're trying to find the distance of how far the brick fell within the next 3 seconds. So we're trying to find out, but what was D? So we're not trying to find the final velocity, even though we don't have it. But we are trying to find the D, which is our displacement, how far the brick fell. So now let's use the formulas. So which of the 3 formulas can we use to solve the problem? Well, we understand how we're trying to find D, but what's really important is we're trying to find using velocity, the final velocity. So when you take a look at your not applicable variable, we have to apply that to one of the formulas that we need to solve for final velocity. So if we try here, we find the distance, but we have no clue what it is. Over here, usually, we find the t, because there is no t right here. But what about this one? Yes, we're trying to find the final velocity, right over here. So our first problem is going to be right over here. V equals, or final velocity, is going to equal initial, then we have to add that by our acceleration multiplied by our time. So when we do that, we get 0 plus 9.8. Then we have to multiply by 3. When we do that, we get an answer of 29.4 meters per second. But that is a big problem, because even though we found the final velocity, that does not cover the distance. So what we have to do is place it right over here. So we know that the brick was falling at a speed of 29.4 meters per second once it fell 3 seconds. But we're trying to find how far it fell, not how fast it fell. So what we have to do is now find another one of these equations or formulas. So now we're trying to find what D represents. Here is an awesome strategy how I like to choose my problems and choose my formulas. So notice that we are trying to find D. What we have to do is, if you take a look at some of these equations from here to here, notice that there's not a D right there. There is a D right here, but we have no idea what D is. So this formula is out of the box. This one's usually solved for your final velocity, which we pretty much already did. And yes, there doesn't seem to be a D right there, but it's not really going to help us out. This formula would be very helpful for finding any kind of velocity, so that is kind of out. But hang on, what about this one? Yes, it does give it away by having that D right there, but if I just do this and ignore the D, notice how the parts inside the formula does not have a D representing displacement inside it. That tells you that the not applicable is going to apply for that. So if we do the math over here, here's what we're going to have to do. Our D is going to equal initial times your times, then 1/2 of A, then times squared. So we have 0 and we have 3 seconds. Multiply them and they become 0. 0 plus 1/2 of 9.8, negative 9.8, because that's your falling speed, multiplied by 3 squared. 3 squared is going to represent 9. and 1/2 of negative 9.8 is going to be negative 4.9. So we can add the 0, but it won't really have any effect. So here's what happens. What is negative 4.9 multiplied by 9? Our answer is going to be, our displacement is going to be, our brick is going to fall 44.1 meters after the 3 seconds have passed. So if you throw that brick over a tower, no matter what it is, ignoring air resistance, it's going to fall negative 44.1 meters. And that's why we have a negative, because it's literally falling. And that is how we explain what kinematic equations are. I hope this video has helped you understand kinematic equations. Thank you for watching Top Analyze Math Industry. Like and subscribe.